Let's take a look at one last example here in this section. We're going to look at a rational inequality this time. So I want to solve x squared minus 1 divided by x minus 3 is less than or equal to 0. One thing I didn't point out in the last video, and I just want to make kind of a quick mention of, this problem-solving process that we're using to solve quadratic inequalities and rational inequalities, this will only work if you have 0 on one side of your inequality. So if you have any other number over there on the, it doesn't matter if it's the left or the right hand side, we have to have 0 on one side of our inequality, otherwise this process is not going to work. So in this case, though, we've got a rational inequality. We're still going to start by finding your partition numbers. This time, though, we have a rational function. Remember, partition numbers, you're looking for places where f is equal to 0 and places where your function f does not exist. In this case, we are going to have to worry about the case where f does not exist because we have a rational function. If we have 0 in our denominator, that is undefined, which would make our function not exist there. So I'm going to take, for that part, for places where f does not exist, I'm going to take my denominator, which is x minus 3, set it equal to 0, and solve for x. So whatever your denominator is, take that, set it equal to 0, and here we'll solve for x. We should end up with x equals 3. So this is one of our partition numbers. We may have more here because we also need to consider the case where f is equal to 0. So one thing we can do is we can take this whole function, x squared minus 1 over x minus 3, and set this whole function equal to 0. Now, I can't solve for x while it lives in the denominator, so I got to get rid of that x minus 3. So the first thing I'm going to do is, I'm going to multiply both sides by x minus 3. On the left-hand side, these two will cancel, and I'll just be left with x squared minus 1. On the right-hand side here, 0 times x minus 3, well, that's going to leave me with 0. This is also a shortcut that we can take here. When you're thinking about places where a rational function is equal to 0, a rational function is only going to be 0 if your numerator is equal to 0. So I can take x squared minus 1, just my numerator, and set that equal to 0 as well if you want to save yourself a step. You don't have to, but just an option for you if you are interested, if you want to. From here on out, I can either factor this or I can solve this using square roots. Let's go ahead and use square roots here. Let's see, we can add 1 to both sides. That would give me x squared equals 1. And be careful, remember when you solve an equation using square roots, you're actually going to end up with two solutions. You're going to end up with positive 1 and you're going to end up with negative 1. So we can say plus or minus 1, or you can just say positive 1 and negative 1. But we end up with two solutions there. We do need to have both of those solutions. So we've got positive 1, negative 1, and then also positive 3 as our partition numbers. So we're going to use those now to create our number line over here in step 2. Step 2, here's our number line. Let's see, we've got negative 1, then positive 1, then 3. So this time I'm going to have 1, 2, 3, 4 different subintervals that I've broken this number line up into. So that means I'm going to take 4 different numbers and plug it into my function. So we're going to take these one at a time. Let's start with the leftmost interval. I always just work from left to right. So I'm going to take a number on the left of negative 1, and we're going to plug it into our function, which our function is this whole rational function, x squared minus 1 over x minus 3. So for step 3, which is what we're going to do right now, I'm going to take, let's say, x equals negative 2. Again, we're working on this leftmost interval right here. So if I plug that into my function, again, x squared minus 1 over x minus 3, it'll give me negative 2 squared minus 1 over negative 2 minus 3. Here, let's see, negative 2 squared, I've got 4 minus 1. Here I've got negative 5, so here I should have 3 divided by negative 5. Again, I don't care specifically about the exact value here because that might change based on which x value you chose. But it's the sign that matters. Here we ended up with 3 divided by negative 5 or negative 3/5. That's a negative number, so I'm going to put a negative sign over that interval. Next, we're going to take a number between negative 1 and positive 1. I always like using x equals 0 when I can, so how about x equals 0 here? So let's see, this time we're going to have 0 squared minus 1 over 0 minus 3. Here 0 squared, that's 0 minus 1 over negative 3. Negative 1 over negative 3, well, that's a positive 1/3. So it is a positive number, so I'll put a plus sign above that interval to remind myself it's positive. And we'll move on to the next interval. Now I need a number between 1 and 3. How about positive 2 this time? So I'm going to take x equals positive 2 this time. And again, we're plugging this into, just to kind of go back and remind ourselves, we're plugging this back into the function on the left-hand side of our inequality, that x squared minus 1 over x minus 3. So this will be 2 squared minus 1 over 2 minus 3. Here, 2 squared will be 4 minus 1 over 2 minus 3. That's negative 1. Here, let's see, 4 minus 1, I have 3 divided by negative 1. That should give me negative 3. So, okay, it's negative. So I'm going to go ahead and put a little negative sign above that interval. And we've got one more interval to work with. We need to work on the right-hand side of 3. So how about x equals 4? So for x equals 4, here we'll have 4 squared minus 1 over 4 minus 3. Here, 4 squared, I should have 16 minus 1. 4 minus 3, that's going to be a positive 1. 15 over 1 just gives me a positive 15, so it's positive here. So it is positive on this last interval. And I have almost everything that I need now. I say almost here. So one thing I want to kind of I want to give a word of caution here. Please do not make the assumption that just because you find one side is negative, that means the other side of that number is going to be positive. It happened to work out this time. It will not always be the case. It's just not always the case that it's always going to change sign. So you need to take that number, plug it in just to find those signs every single time. Please do not try and take that shortcut because it will come back and get you. So I said we have almost everything we need. And this one's going to be a little bit trickier because it's a rational inequality. So the first thing I want to point out is we're working with numbers which are less than or equal to 0. So we said, okay, less than or equal to 0, those would be your negative numbers. So that means we're looking at this leftmost interval, negative infinity to negative 1, and 1 to 3. So if I wanted to start giving a solution set to this, I would say, okay, my intervals would be negative infinity to negative 1 and 1 to positive 3. The tricky part of these particular problems when we're dealing with rational inequalities is, do I use parentheses here or do I use a bracket? Because we can run into some issues with this on occasion. To determine this, and let me point out why we might have problems here. If I look at this, this says less than or equal to 0. If I take any of these numbers and plug them into this equation and I get 0, then I want to include them in my solution set, which would mean that I want to use a bracket. But how do I know whether I'm going to get 0 or something else? what we can look at is how we found these partition numbers. Remember, at the very beginning of this problem, we said we were looking for places where f is equal to 0 and places where f does not exist. So how did we find -1 and +1? Well, we found those by taking our function and setting it equal to 0. So that means when I take -1 and +1 and plug it into my function, I'm going to get 0. So above those two numbers, above -1 and +1, over here on my number line, let me erase these, at -1 and at +1, we said the function was equal to 0. So I'm just going to put a little 0 above those two numbers, just to tell myself, hey, the function is 0 at those points. The other number, the other partition number that we had here was x equals 3. Well, how did we find x equals 3? We started with the assumption that we were looking for places where f does not exist. So above 3, over here on my number line on this little section right here, don't have a lot of room, but I'm going to try and write just a little DNE right there because my function does not exist there. Oops. So now I should be ready to go ahead and say whether each of these numbers are included. Again, we're working with our negative intervals. So let's see, we said less than or equal to 0. This is what we're trying to solve. So we want to include any values which make our function 0, which, hey, if I look at my number line, here at 0, we said, or excuse me, here at -1, we said our function was 0. So that means we do want to include that number. So I'm going to use a bracket around -1. Here at +1, we said our function was 0. So I'm going to put a bracket around 1. But over here at 3, we said the function does not exist. Saying that the function does not exist is different than saying that the function is equal to 0. So that means I need to use parentheses around 3. So here is my solution set. I have -infinity to -1. -1 is included. Union 1 to 3. 1 is included. 3 is not. Please practice these problems because, again, this problem-solving process is going to come back again later on in the course. It's going to come back in a very, very similar way. So if we get our practice in now, it's going to make learning those problems much, much easier.